We are going to learn about imaginary numbers operations. If you do not know what imaginary numbers are, please look at the video for imaginary numbers linked below. Essentially, we learned I equals the square root of -1, I squared equals -1, I cubed equals -I, and I to the fourth equals 1. This pattern keeps repeating every 4 i's. Let's review some imaginary number operations. The first one is addition. This says a plus bi plus c plus di equals a plus c plus b plus di. A and c are real numbers. What you are essentially doing is adding the real numbers together and then adding the imaginary numbers together. So let's say we have the problem 3 plus 4i plus 5 plus 3i. How do we solve this problem? Let's figure out what a, b, c, and d are. Remember that a and c are real numbers and b and d are the coefficients of the imaginary numbers. So, a equals 3, b equals 4, c equals 5, and d equals 3. So, if we use the formula above, this is equal to 3 plus 5 plus 4 plus 3 times I. 3 plus 5 equals 8. 4 plus 3 equals 7. And 7 times I equals 7i. Therefore, our answer is 8 plus 7i. Now let's say we have the problem 4 minus I plus 6i minus 5. How do we add this? We first need to figure out what a, b, c, and d are. A and c are real numbers and b and d are the coefficients of the imaginary numbers. So, a equals 4, b equals -1, c equals -5, and d equals 6. If we use the formula that is written in white, a plus c plus b plus d times I, this is equal to 4 plus -5 plus -1 plus 6 times I. 4 plus -5 is -1. -1 plus 6 is 5. And 5 times I is 5i. Therefore, the answer is -1 plus 5i, which is the same thing as 5i minus 1. The second operation is subtraction. This says a plus bi minus c plus di is equal to a minus c plus b minus d times I. A and c are real numbers. What you are essentially doing in this operation is subtracting the real numbers together and then subtracting the imaginary numbers together. So let's say we have the problem 8 plus 2i minus 3 plus 5i. How do we solve this problem? First, we have to figure out what a, b, c, and d are in the context of this problem. A equals 8, b equals 2, c equals 3, and d equals 5. So if we use the formula in white above, this is equal to 8 minus 3 plus 2 minus 5 times I. 8 minus 3 equals 5. 2 minus 5 is -3, and -3 times I is -3i. Therefore, our answer is 5 minus 3i. Now let's say we have the problem 8i plus 9i minus 4 minus 5 minus 9i. How do we solve this problem? This is a combination of using addition and subtraction operations. Let's combine the like terms first. 8i plus 9i is 17i. Therefore, we have 17i minus 4 minus 5 minus 9i. Now, what are a, b, c, and d in this case? A is negative 4, b is 17, c is 5, and d is negative 9. Remember, a and c are real numbers, and b and d are the coefficients of imaginary numbers. Using this information, we use subtraction property. We will subtract the real numbers together and then subtract the imaginary numbers together. So we will set up the problem as negative 4 minus 5 minus 17 minus negative 9 times I. Negative 4 minus 5 equals negative 9. 17 minus negative 9 equals 17 plus 9, which equals 26. And 26 times I is 26i. Therefore, our answer is negative 9 plus 26i. The third operation is multiplication. This says a plus bi times c plus di equals AC minus BD plus AD plus BC times I. Let's say we have the problem 5 plus 6i times negative 4 plus I. How do we solve this problem? In this case, A equals 5, B equals 6, C equals negative 4, and D equals 1, since I equals 1i. We first have to do AC minus BD. A times C is 5 times negative 4. Negative B times D is negative 6 times 1. 5 times negative 4 is negative 20, and negative 6 times 1 is negative 6. Negative 20 minus 6 is negative 26. Now, let's look at the second part of the formula, which is AD plus BC times I. We have to do A times D, which is 5 times 1. Then, we have to do B times C, which is equal to 6 times negative 4. 5 times 1 is 5, and 6 times negative 4 is negative 24. 5 plus negative 24 is negative 19. Then, we have to multiply by I, as it says in the formula. Negative 19 times I is negative 19i. Therefore, the answer is negative 26 minus 19i. Let's try another problem with the multiplication operation. Let's say we have the problem 7i minus 8 plus 6 times I plus 5. Before we use the multiplication operation, we want to combine like terms. In 7i minus 8 plus 6, you can add negative 8 and 6 to get negative 2. Therefore, you will be multiplying 7i minus 2 times I plus 5. Now, what are A, B, C, and D? Keep in mind that A and C are real numbers, and B and D are coefficients of the imaginary numbers. Therefore, A is negative 2, B is 7, C is 5, and D is 1. We will now use the formula. AC minus BD equals negative 2 times 5 minus 7 times 1, which equals to negative 10 minus 7, which equals negative 17. Let's look at the second part of the formula. AD plus BC times I equals negative 2 times 1 plus 7 times 5 times I. this is equal to negative 2 plus 35 times I, which is equal to 33I. Therefore, our final answer is negative 17 plus 33I. The fourth operation is division. This says A plus BI divided by C plus DI equals A plus BI divided by C plus DI times C minus DI divided by C minus DI, which equals AC plus BD divided by C squared plus D squared plus negative AD plus BC divided by C squared plus D squared, the whole thing multiplied by I. This may seem very complicated at first, but essentially what you are doing is multiplying by the conjugate. So let's say we have the problem 3 plus 5I divided by 2 plus I. How do we solve this problem? Well, the first step according to the formula is to multiply it by the conjugate. So we will multiply the numerator by 2 minus I, and we will multiply the denominator by 2 minus I. Then, we will get in the first part AC plus BD divided by C squared plus D squared. Let's see what A, B, C, and D are in our original problem. Keep in mind that A and C are real numbers and B and D are the coefficients of the imaginary numbers. So, A is 3, B is 5, C is 2, and D is 1. So what is AC plus BD divided by C squared plus D squared in the context of this problem? This is equal to 3 times 2 plus 5 times 1 divided by 2 squared plus 1 squared. This is equal to 6 plus 5 divided by 4 plus 1, which is equal to 11 over 5. Now, we still have to do the second part of the formula, which is negative AD plus BC divided by C squared plus D squared, the whole thing times I. This is equal to negative 3 times 1 plus 5 times 2 divided by 2 squared plus 1 squared, the whole thing times I. This is equal to negative 3 plus 10 divided by 4 plus 1 times I, which is equal to 7 over 5I. Therefore, our answer is 11 over 5 plus 7 over 5 times I. The fifth operation is the conjugate. This is an operation we covered when we were reviewing division. Before we get into that, we are going to be using the symbol alpha, which is represented like this. So if alpha equals A plus BI, its conjugate, which is represented with alpha with a bar on top, equals A minus BI. And this is what we covered in the division operation. Remember, in the division operation, we had to multiply by the conjugate. When we had the problem 3 plus 5I divided by 2 plus I, we had to multiply the numerator and denominator by 2 minus I. 2 minus I is the conjugate of 2 plus I. So, if alpha equals 4 plus 7I, what is its conjugate? Its conjugate is 4 minus 7I. The sixth operation is magnitude. This operation says that when alpha equals a plus bi, the magnitude, which is represented with alpha within something that looks like an absolute value, is equal to the square root of a squared plus b squared. Now let's think about this. Why is this the case? Why is the magnitude of a plus bi equal to the square root of a squared plus b squared? To answer this, we are going to multiply the square root of alpha times its conjugate. The magnitude equals the square root of alpha times its conjugate. Since alpha is a plus bi, and its conjugate using the operation we just learned about is a minus bi, let's put that in the formula. So we have the square root of a plus bi times a minus bi. If we expand this even further, a times a is a squared. A times negative bi is negative abi. Bi times a is abi. And bi times negative bi is negative b squared I squared. Negative abi and abi cancel, so you are left with the square root of a squared times negative b squared I squared. So let's look at negative b squared I squared. We learned in the video on imaginary numbers that I squared equals negative 1. Again, if you are confused why I squared equals negative 1, please watch the video on imaginary numbers. So, negative b squared I squared equals negative b squared times negative 1. This is equal to b squared. Therefore, the magnitude equals the square root of a squared plus b squared. Now, this is a proof. I showed you how to get the magnitude. However, you do not necessarily need to find the conjugate to solve this problem. Essentially, I can write the magnitude of a plus bi equals the square root of a squared plus b squared. This may seem confusing, so let's try a practice problem. If alpha equals 3 plus 5i, what is the magnitude? So we have alpha equals 3 plus 5i. What are a and b in this case? A is equal to 3, and b is equal to 5. Since the formula says the magnitude equals the square root of a squared plus b squared, the magnitude in this context equals 3 squared plus 5 squared, which equals the square root of 9 plus 25, which equals the square root of 34. Therefore, the magnitude equals the square root of 34. Notice how you didn't necessarily need to use the conjugate to solve this problem.